Here we're proving trig identities by combining fractions. When you look at the original equation, you can see that the left-hand side of the equation is messier or more complicated. So we're going to choose to work with the left-hand side of the equation. Because I have a fraction plus a fraction, in order for me to add those two fractions, I have to have common denominators. Here, our least common denominator is going to be 1 minus cosine x times 1 plus cosine x. If we look at our first fraction says 1 over 1 minus cosine x. That's missing 1 plus cosine x, so I have to multiply the numerator and the denominator by 1 plus cosine x. The second fraction, I have 1 over 1 plus cosine x, and that's missing 1 minus cosine x, so I'm going to multiply that by the numerator and by the denominator. When you multiply the first fraction, the numerator, 1 times 1 plus cosine x, you're going to get 1 plus cosine x in the numerator. The denominator is where you're multiplying two conjugates, and if you recall conjugates, when you multiply them together, the middle terms are going to cancel each other out. So we're going to get 1 minus cosine squared x. In the second fraction, I have 1 times 1 minus cosine x in the numerator, so we're going to get 1 minus cosine x. And in the denominator, it's going to be the same, which is 1 minus cosine squared x. Now that we have common denominators, we can go ahead and add our fractions. So our denominator is going to stay the same, which is 1 minus cosine squared x. And in the numerator, we have 1 plus 1, which is 2. And positive cosine x and negative cosine x are going to cancel each other out. If we look back at the right-hand side of the equation, which says 2 cosecant squared x, you can see that we're not quite finished. The denominator, 1 minus cosine squared x, can be replaced using our Pythagorean identity, which says sine squared x plus cosine squared x is equal to 1. Well, if I subtract cosine squared x from both sides of the identity, you're going to see that I'm going to get sine squared x is equal to 1 minus cosine squared x. We're now going to replace 1 minus cosine squared x in the denominator with sine squared x from our Pythagorean identity. So in the denominator now I have sine squared x, and in the numerator we have our 2. Well, we're still not at 2 cosecant squared x, but the sine squared x and cosecant squared x are related because they're reciprocal functions of each other. If we look at our reciprocal identity, that says cosecant squared x is the same thing as 1 over sine squared x. When we look at our 2 over sine squared x, we can separate this to be the same thing as 2 times 1 over sine squared x. And 1 over sine squared x we just determined was the same thing as cosecant squared x. So we're going to replace 1 over sine squared x with cosecant squared x. So we get 2 cosecant squared x, which again was what we were trying to prove from our original equation.